Hi there, welcome back. In today's session of Advanced RAG Techniques, we are going to explore multiple techniques that could make your RAG application more effective. You might have built a lot of RAG applications by now, even you realize that building the RAG application is one part of the challenge. The other big challenge in building RAG applications is making them to work the way you want, making sure that answers are grounded, they are faithful, genuine, and then there is a less model hallucination. That's what we are going to see, like three different techniques like re-ranking, multi-hop and hybrid search. What are they and how they are going to make your RAG application effective. So this is going to be a multi-series session. In this session, I'm going to introduce the tech stack, introduce the use case, and then build a simple RAG application. In next series of sessions, we are going to build the re-ranking on top of the existing RAG application. We are going to build the multi-hop search, and we are going to build the hybrid search on top of it. So with that, let's get started. So to start with, this is a notebook. So let me first talk about the use case. The use case is building a RAG applications on the 10K documents. So what are these 10K documents? These are all the documents filed by different companies with SEC every year, which contains a wealth of information. So to show you one such document, say this is the 10K document of Amazon. So it will have there about the business, what are the risk factors, and some of the legal proceedings, some control procedures, and then there obviously some numbers on what are the spendings and R&D and what are the risks they see, maybe the supply chain risks or AI risks, about the competition, about the human capital. It contains a lot of information. So what we can do is we can use this document as the questions on this document. So as part of this, we are going to actually have 4 such 10K document, one from Amazon, Tesla, Nvidia, and Apple. We are going to actually load all these documents into our vector database. The vector database I'm going to use is Pinecone. So this part I have already completed, just installing all the required libraries so that we don't waste time during the demo. So this also I completed. Basically, I'm loading from the environment file all my API keys like Pinecone API key, Pinecone index, Pinecone URL. Pinecone is a vector database we are going to use. I'm going to show more about that, actually how we are going to store it. And then DeepSeek is going to be the LLM we are going to use, and Cohere is our re-ranking model. Like I'm going to talk more about Cohere in the next session, but in this session we are just loading all them into an environment variable. The next thing we do is we need to upload all the files which are like Amazon, Apple, Nvidia, Tesla PDF files from my local directory into the Colab, and then so that we can start processing from there. So now we are going to load all these files. Okay, so we'll choose here. I upload all my files. Like I download all this PDF file from SEC site. So I'm going to load all these PDF files into my Colab. And then as far as the code is concerned, I usually use Claude to generate all the code for all these things. So Claude is something, Claude code is really gives you really production type of ready great code. So now I have upload all the files. So the next thing we do is we need to chunk the document. So what is chunking? The reason being, when you are actually dealing with LLM, they have some fixed context window. So you cannot feed entire document, which is infeasible. And also you need to only feed the information which you require. Right? For example, if I'm asking about Apple and I'm asking about the R&D risks in Apple, I want to feed only the information about the Apple R&D risk section of the document, not entire document. So if I can chunk these documents into small chunks, it will be easy for me to pick up read only that chunk from the vector database and then feed it to the LLM. And we also include some metadata with each chunk, like what is the source of this document, what is the section of the document, what is the company this chunk belongs to, what is the year this particular chunk belongs to, some kind of chunk index. So that's what we are going to write now. So first what we'll do is we will use LangChain's recursive character text splitter, which will split, which will basically break down the text into sentences and paragraphs while preserving the semantic meaning of the sentence, right? That's what we're going to write now. So in this section, I'm going to walk you through the codes. I'm going to have this LangChain imports here. So I'm having the request text splitter. I'm seeing the chunk size is 500 character. There's a 50 characters overlap between each chunk. And then we are having this is some type of logic here where I want to extract the file name from the chunk. I want it a section because it is having lot of sections which are important, like a business, risk factors, legal proceedings in 10K documents. I want to see add that metadata so that when I read a chunk, when somebody is asking about the business risk factors or maybe our legal proceedings, I can only pick up those chunks easily because I know that I will look for that metadata, right? That's one of the reason I'm actually storing them in the detecting the sections in my document before chunking. Now again I'm creating a chunk ID to uniquely identify a chunk, and then I'm having get source ID which will actually tell me what is this particular chunk is being sourced from, what is the document, is it we are having Amazon PDF, Apple.pdf, like it tells you the actual file name. Then I'm going to have the process company document which will load this document using Pimeo PDF loader. And then once it loads the document, for now I'm setting the default year as 2024 because all these files are from 2024. And then I'm going to invoke each of these methods, build the metadata like this, and then creating the chunks. And then all the chunks I created I'm storing in this all document, so which will have all the chunks. Maybe once I run this cell, once you see the output, we can also come back to the code again to see like what exactly this is doing. So in nutshell, what is we are doing here is that I'm creating the chunks of the document. We can go through this code in detail, but in summary what this particular code is doing is it is actually creating the chunks. So once I run this code, I can see what is running. So it is first processing the PDF files one by one. You could see that it created around 720 chunks out of 89 pages from Amazon. So the total cat process this one, the section it detected is this section, so it is printing all the chunks. In the end we are seeing how many chunks are there for each section. For example, in this section I'm having 230 chunks and 44 chunks, and then Apple is having 985 chunks, right? So their total chunks are this much, and then we are also having a sample chunk to see, like for example this sample chunk metadata, it's showing company, the section, source, page number, chunk size, right? Now we can also printing the sample data from each section to validate metadata. So what we have done right now is we have taken a big PDF document, we broke it into multiple chunks, and each chunk will have some 500 characters of text and also a metadata. So now what is the next step is that we need to create embeddings out of this particular chunks and then store the embeddings. If you want more details on what is embeddings and what is chunks, I actually have another video called Agentic RAG in my channel. You can actually watch this before this so that you will understand what exactly the embeddings means, what the embedding model means, and how embedding helps. So there are a lot more details are there in that video. Here I'm directly going and doing building the model because I'm assuming that you already know the basics of RAG before you can actually start the advanced RAG techniques. So now we are the chunks. The next process is that we need to create embeddings. We need a vector database. So for that we are using a Pinecone. So before you can use a Pinecone, you have to create a index in the Pinecone. Like you have to create an index. While creating the index, you choose what type of embedding model you will choose. You could use Excel. You could use the models hosted on this one. Like you could use this Hugging Face models, or you could actually use OpenAI models. Only difference is that if you are using OpenAI models, it will be a lot of more expensive because you make an API call to create all the embeddings. Instead of that, I prefer using sentence transformer model from Hugging Face. So in this case, I have chosen this as my model in this one, and I created this index. Then it gives you the host. You can also select the cloud provider you want to have. And then this is going to be dense. We are going to talk about what is a dense and sparse in the next sessions when you come to the hybrid search. And then this is serverless. And one thing I like about Pinecone is that it has got very generous free tier. So even you can store, for example, I stored almost like 3 to 4,000 chunks of data without in the free tier itself. So that's one advantage, and it's very efficient, and it is serverless mode, so you don't have to really worry about installing it locally, setting up everything, right? You can just using API, all you require is API key, you can start storing all the chunks in the vector database. And the other thing is that it has got really good free tier. Now going back to our application here, what we do here is that we are having we are getting sentence transfer model from the Hugging Face. What we are trying to do is now we are creating the embeddings of each of these chunks and then storing these chunks in the vector database. These chunks, the embeddings and the metadata is stored in the vector database. So I'm not going to execute this cell because it takes at least a couple of hours for all these embeddings to be created and tested, so that to save some time, I have already done this task previously and I loaded all the chunks in the vector database. So now we can see that if I can go to my advanced RAG chunk, this is how the chunks are there. So this is the my chunk ID, chunk text, and then company, the page number, section, source ID. So I'm storing all these details in my vector database. You can see that you can, whenever you want looking for something, you can also do some search over here, but you can search only by the ID or something. I can actually say fetch one record. It will shows me like what is the chunk text. This is only capped at 500 characters. So this is what chunk text, and then there will be an embedding. The embeddings for this text is going to be this. So when you actually send the query, you convert your query also into embeddings, and you compare the embedding with this embedding, and then you do cosine similarity, and then all the matching chunks you retrieve, and then when you retrieve the chunks, you can know like what is the actual text of the chunk from the chunk text metadata, right? That's what we are going to do now. So now I already loaded this thing, so I'm not going to execute this cell, but you can actually go through this. All I'm doing here is that I'm actually having the sentence transformer model, which is creating embeddings, and then we are showing the embeddings. So far we have loaded the PDF files. So we have created chunks of the PDF files, and we have stored those chunks in the vector database. The next task is that now you need to, when a user asks a question, you need to retrieve these chunks from the vector database and give it to an LLM so that it can summarize the answer for you. So for that we are using it in LLM, and that's where we are using DeepSeek. So what I'm doing is, first I'm going to get the DeepSeek API key, and then I'm creating this chat DeepSeek object, and then I'm actually using this LLM for all my purpose. So before that I need to first have my LLM ready. That's what we are going to do. So we are going to pass all the required parameters like the model name, the API, and then the temperature. It tells you like how much like how closely, basically it tells you how freedom the model has got in thinking, whether it want to be more freedom, it want to give you more innovative answers, or it basically, typically for RAG applications you try to keep the temperature as low as possible so that it is well grounded answers you will get, and models won't hallucinate, model won't generate something which is not there in the context, right? So now we have initialized LLM, and LLM is ready for use. And again, I talked more about all this temperature, embeddings, everything in my other lecture on the agentic RAG. Please feel free to follow that session to get more details on that. So once we are done, now we are going to have a class. We need to initialize a retriever. Okay, so for that, where we are retrieving, we have stored all these chunks in the vector database. Now when a user query comes, we need to retrieve the data from this Pinecone database. So what we'll do is, so that's why we initialized a retriever class, which is, again we load this sentence transformer, this model name we pass, and then we use Pinecone vector store, and to this we pass our index name. The index name is given here. This is our index name, and then we also pass our the embedding model we are going to use. In this case, we are using this model. So we are passing these things and creating the pinecone vector store, and then from there I am going to create a retriever. So in this retriever I am doing a cosine similarity, and it is telling me get me top 5 chunks which are matching very similar to this, because there could be a lot of chunks but we are interested only top 5 chunks, and then we are passing the top 5 chunks to the LLM for either summarization or asking some questions. So that's what we are going to. Now we are going to execute this cell. When you see, it will do what it will do is it is trying to create the retriever for the pinecone, and then we will be using this retriever, this LLM what we created. We will be passing this as parameters in all the methods, so that when user asks a question, you retrieve from the model, and then you actually answer the query for the user. So this might take some time. Maybe I can pass the video for a few seconds till this is done. So now we have this retriever is loaded now. So now let's build a simple RAG application where we pass a query and then a retriever and LLM. It takes 3 arguments. The user query, the retriever is what we have built, we have executed here. We are having this retriever here, and the LLM is what we are having, the DeepSeek LLM which we created here. Now what I'm going to do is, first I'm going to embed my query, because I need to convert the query which user is asking also into an embedding. Then I can do the search that embedding with the cosine similarity in the actual pinecone database. Now I'm going to query this index. This is nothing but my index in the pinecone database. I am passing this query embedding, and then I'm saying top 5, and then I'm saying include metadata is true, values is false, because I don't need embeddings, I need only the actual text. So once I do that, once I execute this query, I get the response. Next is all about processing this response, and then getting the chunk data from this one, and then converting this metadata chunk. And once I do that, I need to build a prompt for the LLM. I'm saying that based on the following document, this is the user question, this is the context. I'm giving some instruction that use only information provided in this document. If it is not provided, the information is not sufficient, state this clearly, structure your answer clearly, and then if data spans multiple area sources, organize it logically. And I'm also asking to provide specific details. Again, this is very simple prompt. You can actually also structure this based on your requirements. And then once I have this prompt, I'm actually going to invoke this with this prompt, and then I'm going to get the answer, and I'm going to display this answer here. So what I'm going to do is 3 steps. One is that user is passing a query, I'm converting the query into an embedding, and I'm going to search the vector database with that embedding, getting all the data, and then I'm processing the data, and then creating all the metadata from the chunks which I received, and then passing that as a context to the LLM for the query. So now we'll just execute this. So this is the method is created. Now the method is ready. All I'll do is now I'll ask it maybe summarize key points in Apple 10K document. Let's see that what happens. So now I'm executing this query. Now it is going and then retrieving these chunks. You can see that chunk 1, chunk 2, chunk 3. It got 5 chunks. Maybe it is getting something from the business, the financial statement, executive compensation. It is getting from controls and procedures. You can see that it got 2 executive compensation chunks. We'll see why. Okay, now it just got the chunks. Now it is passing these chunks to the LLM to get the answers. Now we got the answers. This is a key observation. The 10K, this is what the it is giving us where exactly in the document also, and then it is also seeing some what are some missing information. It is not able to find the financial performance or product segment details or some risk factors, some shareholder data that is missing. We'll see like whether in the next coming sessions, if at all, is there a way for us, for the model to figure out the missing information. That's what we'll see in the multi-hop search query, like how we can actually address this type of issues. So this is the summary of a simple RAG application. So what we have done is we just took the PDF files of 10K documents, created them a chunks out of them, we loaded them into a pinecone database, a vector database, and then we created a, by creating embeddings, and then I have initialized an LLM, which is a DeepSeek LLM, and then I have initialized a retriever for the pinecone. Now I create a simple RAG application which will take the query, convert the query into embeddings, and then invoke the pinecone database with that, and then gets all the chunks and pass that as a context LLM to answer the question, right? So this is about simple RAG. In the next session, we are going to see the re-ranking part. Now I am getting only the 5 chunks, but let's see what is the re-ranking means. How do I better rank the chunks I retrieve? And we are going to see like what is the re-ranking, how it works internally, everything in the next sessions. So see you in the next session about the re-ranking. Till then, thanks for watching this.